In this video, I'll try to help you understand how the useReducer hook works in React.js. Now, to understand this in a better way, my goal here is to go through the official React.js documentation and try to read and understand how the useReducer hook works. And after that, we'll also try out a little example and try to figure out or understand better how this hook works. And if this video does well, then I'm also planning to upload a few more videos on useReducer hook by implementing complex tiny projects using the useReducer hook itself, so that you guys can get a much better in-depth understanding of how this hook works. So for this video, let's stick to the basics and try to understand what useReducer does. And so first of all, you can see that useReducer is an alternative to useState. Alright. So useReducer accepts a reducer of type state action. So the useReducer that we have over here, it accepts a reducer, which is nothing but a function that includes two parameters, state and the action. And it's saying that this reducer function returns a new state. Alright, so useReducer accepts a reducer of type state action, basically a function that returns a new state, and returns the current state paired with the dispatch method. So useReducer uses reducer, which is a function that returns the new state, and this useReducer along with this reducer method returns the current state paired with a dispatch method. So this useReducer along with reducer returns a state, the current state, along with a dispatch method. Alright, and this reducer returns us the new state, the updated state that we require after performing certain actions. Alright, so if you're familiar with Redux, of course this makes it way more easier, but for now, the way to start understanding how useReducer works is, over here, the main thing to know is the useReducer is a hook which takes a reducer, which is a function that takes the type state and action as its parameters, and it returns a newly updated state. And useReducer as a whole, this function, returns a state and dispatch. So useReducer is usually preferable to useState when you have complex state logic that involves multiple sub-values, or when the next state depends on the previous one. So basically, if you have a counter or a cart system, let's say, where you add products, delete products, or a to-do application where you update, add to-dos, etc. In these cases, useReducer is extremely useful because it brings all the complex state logic into one place. And in scenarios like these, such as cart system, to-do applications, and counters, the state always depends on the previous state. Alright, the state always depends on the previous one. So for example, in the counter, whatever the next number will be will depend on what the previous number was, right? And similarly, in a cart system, whatever product you add in the cart depends on whatever you had in the cart previously, right? So they are all interlinked. So when the next state depends on the previous one, in that case also useReducer becomes very useful. All right, now useReducer also lets you optimize performance for components that trigger deep updates, because you can pass dispatch down instead of callbacks. Now this is a very important part. Now most people, I have noticed during interviews or when asked about useReducer, they are not able to give a justification to this part. The part where how useReducer allows us to optimize the performance of components. They just know this, that it optimizes the performance, but they do not know the reason behind it. So the reason behind it is because you can pass dispatch down instead of callbacks. Now to understand this in a more deeper way, I'll also show you an example of it later in the video, so don't worry about that. Stay tuned for that. Now before we do that, first let's understand how useReducer actually works. So over here they have given a counter example, right? Now what I want to do is, I'm going to go to my own code, my own VS Code, and I'm going to implement this counter as well. And we are going to make sure to implement the counter by using this example over here. Now I'm going to break this example down so you understand this in a much better way. So what I'll do first is, I'll open my code, and from here I'll just get the return statement, because we don't want to spend too much time typing. So I'll just paste that over here. So right now the state and dispatch are showing these red lines because obviously we do not have them declared yet. So first of all, to help you understand this better, let's just remove this. I'll just remove this and keep this empty. I'll remove whatever's there in the dispatch. Let's keep this empty as well. Let's just add some empty string, and I'll remove this as well. And this will also be an empty string. So we have this plus to increment, minus to decrement, and this count, which will display what is the current counter value. Now let's initialize the useReducer hook first. So first of all, what I'm going to do is I'm going to go over here and I'm going to say import, let's get React, and then useReducer from React. Now after this, the next thing is, how do we initialize our useReducer? So over here you can see the useReducer takes two parameters over here, reducer and initial state, and it returns state and dispatch. And don't worry, there's also another thing to know about useReducer. It can accept another parameter which I'll talk about further in the video, so just stay tuned for that. So first of all, this is how we get started with useReducer. State dispatch is returned from useReducer. This is a function, let's say, and within this function we pass two parameters for now. One is reducer and the next one is the initial state. Right now we of course need to create these two. So what I'll do is I'll take this, and as you remember over here in the documentation, accepts a reducer of type state comma action which returns a new state. So this is a function. Okay, so the reducer accepts this type, and this indicates that reducer is a function. I'm just showing that to you line by line so that you can understand in a better way regarding how to read the documentation in a much deeper way and understand how things work. So let's say I'll create a function. We'll just name it reducer. It accepts state and action, and this is going to be a function itself. All right. So for now, the reducer is supposed to be a function that accepts the type state and action. All right. Now next is the initial state. So if you remember in useState, I'll just quickly give an example here. Let's say I name this counter, set counter equals to useState, and then let's just initialize this with 0. So this is how we do it in useState, right? But in useReducer, this is where we declare the initial state. All right. This value will be holding the initial state. So this counter, which is initialized with 0, will be present in this initial state, similar to how it happens in Redux. So what I'll do is I'll take this initial state and I'll also put that over here above the function, and I will initialize this with something. So let's say in this case, we need counter, or let's just call it count, and count is going to be initialized with 0. All right. And we should also add const over here. Yeah, that's that. Now we could have either done it like this, or I could have also done something like this. I could have just directly made this an object and passed count as 0. So either of these ways work, but I prefer using initial state as a variable and putting it over here. So basically whatever you put in this second argument is going to be the state that you want to initialize as. That is going to be the same as, you know, declaring counter over here for useState. We can remove this for now, and let's also remove useState from up here. Now the next thing to do is, we already have the initial state, but now we need to utilize the initial state in the reducer to be able to update the state. So wait, let me just get that back, the counter. So in useState, we used to use this set count to update the state, right? Now since the useReducer hook is also a hook that manages the state in a React application, so you would wonder, how does useReducer update the state then? So in useState, we used to use the set count, but in useReducer, we are going to utilize the reducer to update whatever state we have. So that's basically the use of reducer over here. Reducer is going to be a function that takes the state and action, and it returns a new state. So that's what the reducer does in the useReducer. It's basically a function that updates the state within the useReducer. So similar to in useState how we used to have set count, in useReducer we use the reducer for that, the reducer function basically. I'll remove this now. So now in the reducer, we want to increment as well as decrement the count variable that we have within the initial state. So now your next question might be, how do we access the initial state within the reducer itself? Because the reducer is updating the state, right? Updating the state and returning a new state. So how are we accessing the count within the reducer? Now that's exactly where dispatch comes into play. So over here, you can see it accepts a reducer of type state action new state and returns the current state paired with the dispatch method. And dispatch method, if you know about Redux, it would become easy. But if you don't know much about Redux, then dispatch is what allows us to update the state. So dispatch is going to allow us to call the reducer function, and within the reducer function, we update the state, right? So you just need to remember that the reducer function returns us the updated state. And how do we access that reducer function? We access it using dispatch. And since dispatch is declared within our app itself, so we can utilize this dispatch anywhere within our app or JSX, anywhere we want, to access this reducer, which ultimately returns us the updated state. Because how useReducer is built is that it returns us something called dispatch, which is connected to the reducer behind the scenes. You don't need to know how they have implemented this behind the scenes. All you need to know is dispatch is connected to the reducer. So whenever we pass something in the dispatch, it's going to call the reducer, and within the reducer, we always, as I said, return the updated state. So all we need to know for now is to update the state, we need to utilize dispatch within our app. And once we call dispatch, it automatically is going to look within the reducer, and then it's going to try to update the state based on some conditions. So this reducer already takes the state. So if I console log within reducer, if I console log state within the reducer, once we have called the reducer from our app itself, then if I console log state, we are always going to get the state value, which is count equals to 0 at the moment. But to be able to call this reducer, we need to utilize dispatch. That means in our decrement and increment button on clicks, we need to utilize dispatch to be able to call reducer and update the state. So similar to how when we use useState, we do something like, set, count, and then we pass the updated value here. Instead of that, for useReducer, we are just going to write dispatch. This will be a function. And then once this is done, it's going to call the reducer itself. But we need to differentiate whether we are trying to decrement or increment. So for that, we need to pass some sort of data within this dispatch, which can help us differentiate within the reducer function whether we are trying to decrement or increment. So let's say for now I just leave it as dispatch like we have over here, and I try to console.log state. All right, I just try to console log state, and we have the dispatch in the decrement on click event. So let's go to our browser, let's open up the React app, inspect element, let's go to console. Now let's say I try to decrement, and as you can see over here, we are able to view the count 0. Now this is not doing anything because we are simply just console logging the state, but this clearly means that once we use dispatch and we call it like this, it looks for the reducer function and it tries to return whatever is there within the reducer function. And this also means that the state that we have over here, which is built in by the useReducer behind the scenes and is accepted by default by reducer, it shows that this state refers to the initial state when we call it the first time. So it means that this state always has a reference to the current state within the useReducer. Alright, because as you can see, the moment I hit the decrement button, it console logged the state which had the count of 0. And don't worry, you might wonder why I'm getting this console log twice. That's because we have React strict mode turned on. If we switch that off during development mode, then this will just be logged once. In the production application, strict mode automatically gets disabled, so this doesn't come out twice. This is only for development purposes. So you can see console log state has access to the initial state. So if I also passed dispatch over here, we know that this will also give us the state. This will also go within the reducer and try to do whatever is there within it. But the point of concern is, how do we differentiate whether we want to increment or decrement within the reducer? For that, just like any normal function, just like when we call, let's say, any normal function, let's say within this I say test function, and we call a function, and within that we pass some parameters, like let's say this is click or something. So in the same way, this dispatch can also take some argument within it, which is going to help us differentiate within the reducer whether it's a decrement action or an increment action. So let's say I just pass decrement within this dispatch, and in this console log I replace the state with action. Now if I click on decrement, let's see what happens. Click on decrement, and there you go. And when I clicked on the minus button, you can see the action decrement. So this means whatever we pass within this parenthesis is mapped to the action itself. So the action becomes whatever we pass over here. Pretty simple, right? So that means when we use dispatch over here, it calls the reducer and goes within that function, and whatever we pass within the dispatch as an argument is nothing but the action itself, right? Pretty simple. So if you want, we could use if else statement, but I'm just going to use a switch statement over here because that's the general practice. So usually what people would do is they would do something like action, and then based on this action, we are going to have some cases, and based on that we can decrement or increment. But what is more generally acceptable in the React community is, instead of directly passing decrement as a string, it's preferred that we pass it as an object and name this as type. And I'm going to do the same thing for the other dispatch as well, but I'm going to call this increment. And you should of course know how switch statements work. Over here, instead of action, I'll say action.type, because previously we were just sending decrement, so decrement was mapping to the action, but now I'm sending type along with it. So to access this decrement, we have to use action.type. because now the action is going to become this object as a whole. The action is always whatever is there within this dispatch, all right, this part over here. So this action would be an object, and we need to access the type property to be able to differentiate between decrement and increment. So we use action.type. So now all I'm going to say is, for the case of decrement, let's copy and paste this here. I want to return an object, because our entire state is an object, right? So I also want to return an object which will have the count property similar to how it has over here. And if you remember that useReducer is usually preferable to useState when you have complex state logic that involves multiple subvalues, or when the next state depends on the previous one. Now in this case, the next state does depend on the previous one, because the new count that will be returned from the reducer depends on what the previous count was, because based on that we are decrementing or incrementing. So the new state object will obviously follow the same pattern as the actual state object. So this will be nothing but count, and this count will have the updated count value, which is nothing but state dot count minus 1. Pretty simple, right? I'm just going to save this, and then you can see a lot of warnings over here because we need to add the default case and all that. Don't worry, we'll add this soon. So I hope you understood what this is doing. This is returning a same object like this, and we know that this state only has one count property. So we are directly saying this new object that we are returning should have the count property, and it should have the updated value for the action that we are performing on it. And we are performing the decrement action. In the decrement, we want to decrement the count by 1. And how do we get the current count? The current count is received by the state within the reducer itself. So we use state.count, as I had shown you by console logging, that when I console log the state, it gives me this object count 0. So all I have to do is state.count, which is going to give me the current count, which was 0, and then we do minus 1 over it. So we are not updating the count state directly. We are only passing a value to this new object count property, which is nothing but the existing state.count, and then we are doing minus 1 on it. So that's just going to return us a new value for the new count object. Now let's just copy this entire thing and do the same for the case of increment as well. I'm going to copy this and paste this over here, and instead of minus 1, I'll do plus 1, and after this I'll also add a default case. We always need a default case in switch statements. And then over here, let's say I'll just return whatever the state was. So if none of these cases match, we'll just return the original state that we have, the current original state. All right, so you can see those warnings also went off, and this is literally all we need to do here. So now let me just check this out once if this works or not. But hold on, before I do that, we need to be able to display the count, right? So over here we have this count text which is supposed to display the count value when it decrements or increments. And how do we get the count state? So as you can see over here, this state is unused. useReducer returns a state and dispatch. Within the state, we are going to have whatever values we declared for the state itself. Now within this state, all we have is count. So this state right now is nothing but an object which includes the count property. All I have to do is state dot count. And if I save this and I go to my browser and I go to my code over here and I just remove this, now I'll just zoom into this and I'll try to increment. There you go, you can see it perfectly increment. And if I decrement, you can see this decrement as well. So if I increment, it works. If I decrement, it works as well. You can see that this useReducer put everything in one place. And the main goal of this video was to help you understand why we use this reducer function, what this reducer does over here, what this initial state does over here, what this state and dispatch do respectively, how do we call the reducer itself, which updates the state from our own application component, and how do we pass data within the dispatch to be able to utilize it within our reducer in order to be able to return the new updated state. Now this covers most of everything that's there in useReducer, but there are a few more things you should know about. So in the documentation here, you can see, if I go down, you can see over here that React guarantees that dispatch function identity is stable and won't change on re-renders. This is why it's safe to omit from the use effect or use callback dependency list. So it's just saying that do not use the dispatch within the use effect or use callback dependency array. That's because the dispatch doesn't change on re-renders. So whenever a state changes, the component re-renders, right? But the dispatch never re-renders. So do not use this within the dependency arrays, because this won't ever change. So your use effect or use callback won't run as well. Now that is one thing to note. And this note over here is also going to help you understand this part. that useReducer lets you optimize performance for components that trigger deep updates, because you can pass dispatch down instead of callbacks. And the advantage of passing dispatch down instead of callbacks is that dispatch function identity is stable and it won't change on re-renders. So dispatch doesn't re-render itself, so this will save you a bunch of re-renderings if you use the useReducer and pass the dispatch down the child components instead of passing down callbacks that we usually do, because it's going to save you on a bunch of re-renders and ultimately optimize your performance. Now the next thing is specifying the initial state. There are two different ways to initialize useReducer state. You may choose either one depending on the use case. The simplest way is to pass the initial state as the second argument. All right, so we just passed it by declaring the initial state on top, but I also showed you that we could directly put this over here. That would be the same, because in the reducer itself the state is going to map to this anyway. All right, so here there's another note. React doesn't use state equals to initial state argument convention popularized by Redux. The initial value sometimes needs to depend on props, and so is specified from the hook call. Instead, if you feel strongly about this, you can call useReducer, reducer undefined to emulate the Redux behavior, but it's not encouraged. So basically, if you have used Redux, then in Redux what we do is, instead of state over here, we just write state equals to initial state. But in this case, for the useReducer, it's recommended to use state as it is and not state equals to initial state, because sometimes the state might depend on a prop instead of us manually declaring it like this. So that's why it's always good to use initial state over here, because we could simply pass down whatever prop values we have over here to this initial state, and that initial state will initialize with those props value. So that is why we do not intend to write state equals to initial state all over again, because it could just reset whatever we have in the situations where we need the initial state to depend on the prop. So do not use state equals to initial state and just keep it as state itself. And then after that, remember I told you about one more thing, that the useReducer can accept another argument. So that is explained over here. There's something called lazy initialization. You can also create the initial state lazily. To do this, you can pass an init function as the third argument. The initial state will be set to init initial argument. It lets you extract the logic for calculating the initial state outside the reducer. This is also handy for resetting the state later in response to an action. So this is also pretty self-explanatory. What it's saying is you can use another third argument, init, over here. So basically we can write something called init over here. We obviously don't have this declared. So what this init does is, instead of initializing the state over here or creating a variable initial count over here, declaring it as the initial state and passing that variable here, what we can do is we can pass init, and init is going to be equal to the initial state when the component first renders. All right, so the initial state for the first time is going to be equal to whatever this init returns. So the init, as you can see over here, is a function in this case, and whatever this function returns, that is going to be the initial count for the first case. So until for the first time that we enter our application and in our component mounts, the initial count over here is going to be equal to whatever the init function returns. Right, so the init returns count, initial count, so the initial count is going to be equal to that. So basically you can put parentheses and pass a value within the init, which is going to be initial count, and then the initial count over here is going to be equal to this returned object count value. All right, now the benefit of this is you can perform some complex logic over here, because suppose if you're not using init and you want to have an initial state over here, which by default takes a value that comes out from a complex calculation. So let's say there's some complex calculation going, there are like 4 to 5 lines that ultimately returns a value, and that has to be the initial state. So in that case, we cannot write all that over here, right? So in that case, we just pass an argument in it, create that function, perform all that calculation within this function, and return it as an object with the property being the state and the value being the value coming out from the complex calculation. And that return value is going to be equal to the initial state, which is the initial count in this case. And the other advantage to this is it lets you extract the logic for calculating the initial state outside the reducer. We just talked about that. The other advantage is this is also handy for resetting the state later in response to an action. So the init is always going to contain the first state of the application, right? So when the component mounts, the initial state is going to be contained within this init, right? So anywhere in our reducer where we have multiple switch case statements, if you ever want to go back to our initial state, so let's consider I have incremented, decremented the values multiple times, but anytime if I want to, let's say, initialize, reinitialize my state again or reset my state again, then within this switch statement itself, you can just make a case reset and call that init function itself, because that init always returned us the initial state, right? If you remember. So if you make a case reset and call the function init and return it, then since reducer returns the updated state is going to be equal to the initial state again. So obviously for that, in the action within the payload, you will have to pass a value as well, the initial value that you require to pass. And like we have passed type over here, you can just put another property within this object and pass the payload value, that is going to be the data. Now to utilize payload within dispatch, I have planned to make another tutorial, two more tutorials actually, where I'll be trying to create two complex systems. One will be the cart system and the other will be a to-do application. Both these applications will be built using useReducer itself, and over there you will understand how we can pass payloads and do a bunch of other things with useReducer itself. But in general, this is how useReducer works. This is how it works in a deeper level, and this is how each of its default declared values mean in general when you utilize them in your application. Now lastly, if you go down here, bailing out of a dispatch, if you return the same value from a reducer hook as the current state, React will bail out without rendering the children or firing effects. React uses the object.is comparison algorithm. Note that React may still need to render that specific component again before bailing out. That shouldn't be a concern because React won't unnecessarily go deeper into the tree. If you're doing expensive calculations while rendering, you can optimize them with useMemo. So all this is saying is that the reducer updates the state, right? So if the new state returned by the reducer is equal to the previous state, then every time the state changes, the component re-renders, right? So when the component is about to re-render because of this reducer, but it sees that the reducer has returned the same state as the previous state, then React will bail out without rendering the children or firing effect. So React will render the component, but it won't re-render its children again, because that's unnecessary, right? The state is the same as the previous state, so why does it need to again re-render all its children elements as well? So if the state that you're returning from the reducer is equal to the previous state, the re-rendering which will happen won't re-render all the children within that component itself. Then that's because React uses the object.is comparison algorithm, and I have this over here, the MDN docs. So object.is determines whether two values are the same value. Two values are the same if one for one of the following holds, and you can go and read through each of these conditions. So using the object.is, it decides whether the state has changed or not, and based on that it decides whether to re-render the child elements or not within the component. Now that's all for the useReducer. Now one last thing that I can also explain is useReducer lets you optimize performance for components that trigger deep updates, because you can pass dispatch down instead of callbacks. So if I click this, we get this over here. This says how to avoid passing callbacks down, and this is pretty simple. All the documentation says over here is we can utilize useReducer and pass the dispatch within the child components to prevent re-renders. So let's say generally when you have a component structure and you have child elements over here, like, you know, within the return you have multiple child elements, let's say, and you have a function over here in this application that's doing something. So when you pass that function to that child element, the function is passed down as a reference, right? So whenever state changes, a new reference to that function is created, which ultimately makes that child component re-render again. But if you want to avoid all these re-renderings, you can just simply create a context. Now understanding how to use useReducer with context is completely a different tutorial and a completely different concept, which I'm also thinking to make a video on. So if you want a video on that, just comment down below. So basically, context allows us to globalize things, right? It allows us to share state within different components. So basically we can just create a context variable, and within our component, when we have this useReducer declared, we know that the to-dos reducer is going to update the state, right? So it's useReducer, since it returns dispatch. What this means is when we use a context, we use providers over here, right? We wrap the child components with provider, and whatever value we pass to that provider is shared between all the components that's within this provider. So if there were 2-3 components instead of just one component over here, if there were 2-3 components, that value would have been shared across all those components. If we pass value equals to dispatch, and let's say we have within this useReducer a state initialized, and we want to update that state itself, then instead of passing a callback which updates that state, we can directly just pass dispatch as the value, and the to-dos over here is going to be equal to the state to-dos over here. So basically this component is taking to-dos as a prop, which is nothing but the state, the initial state. And if you want to update these to-dos, when we use useState and we pass set state and the state variable to the child components, and we try to update the child component with the set state prop that we passed on from here, in that case a re-rendering occurs. But when we pass dispatch like this to the provider, the dispatch is also accessible within this component, right? Because we have passed the value dispatch over here, so it becomes global within all the nested children elements. So within this deep tree components, we can utilize dispatch, use context, to do's dispatch. We can basically get the dispatch value from the use context because we have passed it in the value. And then within this component, if we want to update the to do, like over here on handle click, we are adding the to do. If you want to update the to do state, we can use dispatch from the context and we can update the to do, and that will ensure that the components do not re-render again. And that is why it's written over here that useReducer lets you optimize performance for components that trigger deep updates, because you can pass dispatch down instead of callbacks. So this dispatch over here, which we are using to update the to-do state, will not cause deep re-renders. It will prevent a lot of re-renders that generally would occur if you used callbacks to update the state. So that is also one more massive benefit of using the useReducer hook. So this is all about the useReducer hook. These are all the important concepts, at least for what the React.js documentation says. You can obviously manipulate useReducer in various different ways, but the general idea of how to use useReducer works on exactly how it's mentioned over here in this documentation. But the exact or general idea of how useReducer is supposed to be used and what do all of those arguments mean within it is explained within this documentation, and I hope I did a good job explaining that as well. Now this will obviously give you a general idea of how to implement useReducer. I hope I've taught you all the important things that you need to know, because I covered everything that's there in the documentation for useReducer. Now in the future I'm going to come up with multiple videos, as I said, which will be revolving entirely around this useReducer hook, and that's going to help you understand things much more in a better way. So this will be an entire series focused on useReducer, and I'm sure this is going to help you a lot moving ahead. So if you're interested to watch the series, just comment down in the video, and if you enjoyed this video, then don't forget to like and subscribe, and as usual, stay tuned for more.